Scatter diagram. How to use scatter diagram as a tool for data analysis. Scatter diagram, what is it? Scatter diagram is a graph that is used to examine whether two variables are interrelated or not. If they are related, the data falls along a curve. This relationship can also be measured statistically. Sometimes there may be a suspicion that two variables are related. When you want to prove or disprove this suspicion, the scatter diagram may be used. Scatter diagram is a visual way of checking it out. Where can you use scatter diagram? You can use it when you want to understand a process and look at how one variable changes with a change in another variable. You can use it to understand the cause and effect. You can cross-verify the result of a problem solving by checking out the change in one variable when another variable changes. Let us understand scatter diagram with the help of an example. In a foundry, the moisture of the sand is very important to maintain the quality of the mold. If the mold has to be strong, a certain moisture has to be present in the sand. The team is trying to solve the sand drop problem. As a part of this, the team may want to understand the relationship between moisture and sand drop. They may expect a negative correlation between moisture in sand and sand drop rejection. If the moisture is reducing, the rejection due to sand drop is expected to increase. The team may collect the moisture data every hour in the line, and they may also monitor the rejections in the line every week. Naturally, there may be a drop in moisture in the afternoon of a summer day. If there is positive correlation, the graph may look like this. Positive correlation means, if the moisture is increasing, the rejections are increasing, and if the moisture is decreasing, the rejections are decreasing. Hourly moisture data is plotted on x-axis, and number of rejections every hour is plotted on y-axis. If there is negative correlation, the graph may look like this. Negative correlation means, if the moisture is increasing, the rejections are decreasing, and if the moisture is decreasing, the rejections are increasing. Hourly moisture data is plotted on x-axis, and number of rejections every hour is plotted on y-axis. If there is no correlation, the graph may look like this. If the rejections are not dependent on the moisture of the sand, then the data may look like this. If there is very little correlation, the graph may look like this. If the rejections are not dependent much on the moisture of the sand, but there is some amount of correlation, the graph will look like this. How correlation is measured? Correlation can be understood from the shapes of the graphs as earlier shown. But, if you want to put a value to this correlation, you can calculate it statistically. Correlation between two variables can be measured with a formula statistically. Formula is shown below. If R is equal to positive 1, then the two variables are perfectly positively correlated. If R is equal to negative 1, then the two variables are perfectly negatively correlated. If R is equal to 0, then there is no correlation between the two variables. You can use Excel to calculate the correlation. You do not have to worry about doing this calculation manually. Let us look at another example from made-up garments industry.